Right, thanks very much for the introduction, Rob. Thanks to the organisers from AESIN for inviting me and giving me the opportunity to tell you about Clas-SIC. Let's see, so that's cell. Oh. There we go. Yeah. So I want to tell you about Clas-SIC, which is the UK's only commercial power silicon carbide wafer fab. So in my talk, I'll give you an introduction to Clas-SIC and how and why we started up, the position we seek to take in the power semiconductor supply chain, some of our solutions and offerings, and then talk about some of the projects we're actually active in for advanced automotive. So escapes we mentioned, we're in that. There's a Celeritas program, the SIC-MAP, which Nigel has alluded to, was developing silicon carbide MOSFET applications unlocked by PDK for both 1700 and 3300 volts. And then I want to also talk about beyond SIC-MAPs and alluding to solid-state transformers. And finally, I'll conclude. So the motivation for setting up Clas-SIC was basically we had a visionary founder who saw the opportunity afforded by silicon carbide in the power electronics market. You could see the efficiencies that would unlock, and his view has been substantiated by the direction the market's going in, with things really taking off. There have been projections for a long time from Yole and CSAC as to how the market's going to take off, and things really have, with the demand outstripping supply. So that was the motivation, and an opportunity to realise that motivation was when the Raytheon mixed silicon carbide wafer fab closed in about 2017, and suddenly a key skill set became available. Much has been mentioned about skills and the key nature of skills to this industry, and that was absolutely critical, and the founder actually realised the value of those skills actually becoming available, and those were secured, and a new site was then set up at Clas-SIC Wafer Fab, but this time for dedicated to 150mm silicon carbide processing, primarily for the power silicon carbide industry. So that was matched not only by acquiring the talent, but it was also matched by acquiring dedicated production facilities and dedicated equipment to fabricate silicon carbide devices. And you can see our factory there, but so there's a major amount of investment there. It's been described as a bit of a TARDIS. Looks fairly plain from the front, but actually an awful lot behind that. There's almost the same area of facilities as there actually fabrication footprint, and you can see the complexity at the bottom left of actually just one small part of the fab. That's sort of the grey area behind that, or in front of that, there's the actual equipment which is shown at the bottom right. That's the actual clean area, and that's multiplied many times throughout the wafer fab. So it's a very significant investment that we've been fortunate enough to secure angel investment funding for. So we're located in the east coast of Scotland, just north of Edinburgh, and we are the world's first dedicated open 150mm silicon carbide foundry. So we are open for business now, and it represents a sovereign UK capability which is unique. And that capability is now available so that it can drive innovation in the semiconductor power industry, and later on in my presentation I'll actually talk about some of the innovations that we're actually helping drive. So just where the Clas-SIC fit in the value chain, what's our value proposition? So what we're offering, so we're seeking to offer, is fast prototyping for silicon carbide wafer fabrication to accelerate R&D, and we're doing that by a lot of standardization. So what we're trying to do is develop standard process steps, and then build those process steps together to create standard design kits, for example, for diode fabrication, for MOSFET fabrication, so that customers can actually use those common processes all the devices would actually be fabricated on a common process, so that really upscales things. It reduces NRE, and practically eliminates NRE, it reduces manufacturing complexity and costs, and helps drive costs down and manufacturing efficiencies up. We were successfully doing that with our process design kits and modules. We do have the side of the business as well, where we're actually looking to just offer individual processing stages, so we're quite open to companies actually coming in and asking for specific stages that they don't have to be actually processed, and we're happy doing that for a number of companies as well, although that's not really the core business. So I've summarised in this slide some of our solutions. So at the right-hand side we have the process design kits, which are really the areas that we're working on. So our GBS, MPS, silicon carbide die design kit, that has been issued, and customers have been designing on that. I have got the graphic at the bottom right summarises that, and at the bottom of that it's underpinned by flexibility and customization, so it's extremely flexible. For example, it allows different voltage classes, allows both MPS, GBS options, different terminations, ohmic contacts, Schottky contacts, and importantly as well, it's a reliability proven. We have demonstrated devices that have gone through HTRB, H3 TRB, so that customers can come with confidence and actually design products on this known of a secure platform underneath. We're also working on the MOSFET platforms, 1200, 1700 and 3300. So we already have our 1200 volt MOSFET beta PDK in use. We had a very innovative customer come and design our alpha MOSFET, 1200 volt MOSFET, and that's been very successful. In fact, it really exceeded all my expectations. The customer are very happy with the functionality they're seeing, but our innovation in supplying these has driven further innovation with the customer. They've taken the PDK that we had, they've stretched it, they've squeezed it, and they've added extra functionality and extra components integrated with the MOSFET, which is quite blown me away, but it just showed how innovation could actually breed innovation, so that's been really successful. And we're working on the 1700 and 3300 volt design kits, which are due to launch later this year. Another side, the left-hand side, are just some of the individual process modules which we can stitch together, or which are available to actually put together in a jigsaw puzzle of a different type if a customer so requires. Just one or two things I'd like to clarify, because in discussions with various potential customers there have been some misconceptions or misunderstandings. So I just want to stress that Clas-SIC are a pure play foundry with no intention to market or sell our own branded power devices. Rather, what we're wanting to do is to empower customers to design their platform, to design on our platforms their devices, and certainly not to compete with them while protecting their IP. We do have design support. People are often worried about do you have designers that are actually designing and stealing your ideas. So our design is the design support in terms of mask layout, and also in terms of designing PCM structures to actually test and validate the devices. So it's there in a supporting role, not a competitive role. And really, our business is to support customers through accelerated R&D times and through prototyping all the way to production, so as to fill that gap between the lab fab, the small scale, and the very large fabs. And it's often very difficult to make that jump from the small scale to the large scale. So Clas-SIC are very happy to do that, and that's part of our business as well, so, supporting niche products. So in the last part of my presentation, I just want to talk about some of the activities that we're taking part in with advanced projects for automotive. As mentioned before, there's the ESCAPE project, the end-to-end supply chain. Clas-SIC are there in the middle of that, producing the very advanced silicon carbide devices. we did look at some figures of merit for various devices available in the market, and these devices are certainly way up there in terms of their capabilities. We're making good traction with this. It's an advanced process. It's not an easy process. There's been technological challenges, but we're actually getting through them and getting good results. That's very encouraging moving forward with that. It's exciting to be part of this big, diverse supply chain. And it's all about innovation, both not only device innovation that we're working on, but packaging, then the actual electronics innovation in terms of the inverter, DC-DC converter, the charger, leading to that complete innovation in the supply chain. Now, I also want to talk about the Celeritas programme that Clas-SIC are about to work on. APC funded the ESCAPE programme. APC are also funding the Celeritas programme. This one we have on board BMW as the OEM, and it's all about rapid charging. As was alluded to already this morning, charging speed, battery capacity, big issues. So this project is all about developing ultra-fast charging of batteries, both for electric and for fuel cell vehicles. This is actually the breakdown, the component breakdown for this project. So Clas-SIC providing the silicon carbide MOSFETs, Sprint Power actually providing the electronics. Then we have AMTE providing the battery cells, Eltrium actually doing the integration of the battery cells, and BP involved in providing the cooling fluid to take away the heat that's such an issue for rapid charging. So exciting programme we're looking forward to taking part in when it starts in a few months' time. I also want to mention the SIC-MAP project. So this is one that's been DER funded, and Clas-SIC have been working on this with the CSAT catapult in South Wales. So the point in this one was to actually take their 1200 volt MOSFET PDK and expand that to develop the 1700 and 3300 volt capability. So we're well through that now. It started with some marketing study and then design and fabrication. So we're well on with demonstrating 1700 volt and 3300 volt MOSFETs, getting some good breakdown results at 2.2 kV or 4.2 kV. So things are looking encouraging. We then have to assemble all the electrical results into a PDK and publicise and disseminate that. That's a sort of part of a typical PDK document, and Clas-SIC and CSAT will disseminate through websites, social media, as well as at conferences and via trade press. And what I want to lead on to, as we can get towards the end of my talk, is to link in with what Nigel has been talking about with solid-state transformers. So I probably don't need to say too much because Nigel has said more eloquently than I can about solid-state transformers. But basically what we're looking to do is we have an application for another project to take on the 3300 volt transistors that Clas-SIC are fabricating and develop a solution for solid-state transformers an electric grid that has been described already by Nigel, just taking advantage of the flexibility that the solid-state transformer can bring to the grid, which is absolutely important for the evolving grid and supporting the diversity for electrification and green energy. So in conclusion, I just want to say that Clas-SIC, the UK's only commercial power silicon carbide wafer fab, is now open for business. Our diode and MOSFET process design kits, they facilitate fast time to market for highly customised devices at low cost and high efficiency. We're already fabricating devices for leading edge automotive programs, which is an exciting place to be in, but we're also active in other fields as well. It's not just automotive, we have commercial customers as well who we're actively marketing for, actively fabricating for. So thank you very much for listening.